All right, lesson 7.2, sectors of circles. So in this lesson, we'll find the arc length and area of a sector of a circle. Okay, so first things first, what is a sector? Okay, a sector is a part of the circle. Okay, so one section of the circle. A couple things here. Theta, we always write our unknown angle measure. Pen. Theta, we refer to that as our central angle. Okay, and after lesson 7.1, theta is either going to be measured in degrees or radians. So if theta is measured in degrees or radians, it is a different formula, and we have a slide of all these things put together. But if we look at the arc length, notice that the arc length is part of the circumference of the circle. Okay, the arc length is on the outside. So the formula makes sense. Theta is our central angle. Theta is going to be a part of the whole circle, 360 degrees, and then I multiply that by the circumference of the circle, which is 2 pi r. Now, if theta is measured in radians, the formula is a lot simpler. It's just theta times the radius. If we look up here, if I take my angle measure, and if I simplify this, I get theta over 360, over 180 times pi. That's our exact conversion to go from theta being measured in degrees to theta being measured in radians. Okay, so that, if this is in degrees, it cancels it out. Pi tells me that my angle measure is in fact measured in radians, and that's where this simpler formula is derived from. Okay, area of the sector. So area, notice in here, this is blue. Okay, we represent that with the letter K. So again, if theta is measured in degrees, this sector, the area, is part, theta over 360, of the area of the whole circle. Okay, so pi r squared is area of a circle. If theta is measured in radians, the area of the sector is 1/2 theta r squared. And if we think of what theta times r gave us, which was our area of our sector, that's where the second formula is derived from. Okay, so if we look at this as times r, that's equal to s. Either one is fine. I will say this formula comes back up in calculus, okay, what that area of a sector is. So it is an important one as far as what comes next. Then lastly, the perimeter of a sector. Okay, so perimeter, we know that that's the distance on the outside. So perimeter is 2 times the radius plus s, which is our arc length. Okay. We'll give you a handout of this, all right, so you don't have to write everything down, but there's the difference if your central angle is measured in degrees or radians, and perimeter stays the same, twice the radius plus the arc length. Okay, so find the arc length and area of a sector for a circle with a radius of 8 and a central angle of 50 degrees. Leave your answer in terms of pi. Okay, so arc length is s, central angle is 50 degrees, part of circumference of the circle. So just plugging that information in. So I have 50 over 360 times 16 pi. Simplify that answer. That's going to be part of your homework. Arc length. Arc length, area of the sector is part of the area of the whole circle. Okay, so we get 5 over 36 times 64 pi. Simplify that final answer for me. Find the arc length and the area of a sector for a circle with a radius of 5 and now a central angle of 225. Arc length, central angle divided by 360 times 2 pi r. My radius is 5. So I get 225 over 360 times 10 pi. Simplify that answer for homework. Area of the sector, the fraction, the part remains the same, but now we're looking at part of the area of the whole circle, so pi r squared. 225 over 360 times 25 pi. 25 pi. Simplify that for homework. Do these without a calculator. Your quiz will be non-calculator, so simplifying these fractions is a must without a calculator. All right, find the arc length and area of a sector with a radius of 12 and a central angle of pi over 5. So for arc length, it's just central angle, theta, times radius. Okay, so this one is already simplified. 12 pi over 5. Arc length is part of the circumference or the perimeter, so our units for arc length would be centimeters. Area, 1/2 theta r squared. Okay, so I would get 144 pi all over 2 times 5. So that would give me 72 pi over 5. Area, our units then would have to be centimeters squared. Okay, so try and get in the habit of writing the units on there as well. Arc length and area of a sector for a circle with a radius of 6 and a central angle of 1.5 radians. Okay, now this angle measure does not include pi, but it's still measured in radians. Arc length is theta times r. So that would give me 9 inches for an arc length. Area of the sector, 1/2 theta times r squared. Okay, so that gives me 18 times 1.5. So that would give me 27 square inches for the area. So hopefully you're seeing these are not difficult problems. You just have to remember what the formula is. All right, now given the arc length is 18 centimeters and the area is 24 square centimeters, find the central angle. Okay, so now we know that our arc length is equal to theta times r, and I am going to use radians because it simplifies the formula. I know that the area of the sector is 1/2 theta r squared. But we talked about the fact that if theta r is equal to s, this is equal to 1/2 the arc length times the radius. Okay, so plugging in the information we know. Arc length is equal to 18. So into my area formula, I can replace my arc length with the given value of 18. I know that my area is equal to 24. So times my radius. So I get 24 is equal to 9r. So now my radius, and I'll simplify that, my radius of the circle is going to be 8/3. Okay, we got to find the central angle. Central angle is theta. So now I have to come back to my arc length formula. So arc length was given as 18, theta is what I'm looking for, and my radius we just found to be 8/3. So solving for theta, I would take 18 and multiply it by 3/8. Okay, multiply by the reciprocal. Cancel these, and I would get 9/2. So 27/2 would be the value of theta. I lied. 8 divided by 2 is 4. So 27/4 would be my value of theta. And like we saw in the previous problem, you don't need pi in order for your angle measure to be measured in radians. So theta would be 27/4 radians. Okay, a sector has a perimeter of 16 centimeters and an area of 15 centimeters squared. Find the radius and arc length. Okay, so let's start with our given information. We know perimeter is 2 times the radius plus the arc length. And we know that the area is 1/2 arc length times the radius. Okay, so my perimeter is 16. Area is 15. So looking at these two equations, I'm going to take my perimeter and I'm going to solve it for s. Okay, so 16 minus 2 times the radius equals s. Into my area, I'm going to multiply both sides by 2 to clear that fraction, and then I'm going to replace s with what we just found. Okay, so I'm going to take this and I'm going to make a substitution. So 16 minus 2r there. Okay, times r. So I get 30 is equal to distributing the r. This is a quadratic, so we're going to use factoring to solve it. Add 2r squared, subtract 16r. Now my equation's equal to 0. Divide all the pieces by 2. And now when I factor, factors of positive 15 that add to negative 8, I get 2 different radii. Okay, so if I get 2 different radii, I'm going to get 2 different arc lengths. So first we'll look at radius of 5. If my radius is 5, 16 equals 2 times the radius plus the arc length. 16 equals 10 plus s. So I would get an arc length of 6. Or if my radius is equal to 3, plugging it back into the perimeter, 16 equals 2 times my radius plus my arc length. 16 equals 6 plus s. So then 10 would be my arc length. Okay, so done for notes. Check out Teams for any additional assignment for this lesson.